Welcome to Azure Essentials. If you're in IT operations, in the next few minutes I'll explain how you can get on board with Azure as a unified environment for DevOps. DevOps, as the name implies, is all about fostering a stronger partnership between development and operations disciplines. It's a merger of people, process, and technology aimed at driving greater efficiency and success in bringing new apps and functionality to market quickly and in maintaining and updating these apps throughout their lifespan. What this means to you from an IT operations perspective is that DevOps can help ensure that your operational requirements can be defined collaboratively upfront during the development process and followed throughout the lifecycle. Now, from the developer and test perspective, these infrastructure requirements just become part of the code, a concept we'll explore later called infrastructure as code. This makes spinning up these IT-compliant environments quick and easy. Now, development and operations becomes a virtuous motion as you plan, build, deploy, and operate apps. Gather continuous feedback that you continuously integrate back into the development process in an iterative fashion. Now, as an IT professional, there are parts of the DevOps lifecycle that you'll play a bigger role in than others, but it should always be a partnership. Now, together with your developers, you'll want to plan and define the development, test, and production environments to ensure that the correct guardrails are in place to deliver supportable production quality code, and that you have the right test criteria and SLAs for apps in place before they're released into production. You'll also want to ensure that placement of apps meet your data sovereignty needs and that you continue to work together with your development teams on the ongoing monitoring and iteration of apps in production. So how with Azure do you get a unified environment that makes all of this collaboration possible? Well, first, as you work with your developers, it's worth knowing that Azure is an open platform with lots of choices to support the tools and frameworks that your developers are using. For example, if you wanted to, you could run the whole Linux stack in Azure. Now back to the concept of infrastructure as code, which is a key principle of DevOps. While your developer teams work to get new features out at a fast rate, this is the main way to ensure that you supply them with a consistent, compliant, and repeatable dev, test, QA, and production environment. This allows you to use templates and scripts to define the infrastructure powering each of these environments. Azure Resource Manager templates written in JSON provide the code that allows you to define the required infrastructure. For example, if we look at this high availability template for a SharePoint farm, I'm able to define the required resources, their dependencies, and their orchestration. You can choose from hundreds of templates available in Azure and from GitHub to get started. Now, to control resource utilization early on, as apps are being developed, you can gate these resources and carve up dedicated areas for development and testing within your Azure subscription using role-based access controls in Azure. But to make this even easier, we've got DevTest Labs. This enables you to quickly and easily spin up a pre-production, testing, and staging environment for your developers with the appropriate permissions and scope to control costs. You start by establishing a budget for the lab. Now, as the lab owner, you select the configuration and policies, and then you can select the cost trend option to set the dollar amount and target cost thresholds for notifications. Next, you can assign resources to the DevTest Lab. If you've already got existing Azure Resource Manager templates that define your production environments, you can easily reuse these to deploy instances of the environment, but sandboxed for development and test. Otherwise, you can set up a new development and test environment from scratch. Now, as a lab owner, you just select the range of VM sizes. You can also set the VM quota per user or per lab and define the VM running hours through auto shutdown and auto start. In addition to the cost control policies, you can also control the VM images and templates people can use in the lab. You can select appropriate images for your VMs from the marketplace, or you can build your own custom images. And from here, you can also specify formulas which allow you to further customize the base image so that every time you set up a VM, it'll have a common set of properties. This could include artifacts which comprise apps that you may want to use for testing or other tools that you'd like to install or download. From there, you'll want to grant access to the DevTest Labs environment. Just like Azure in general, this uses Azure Active Directory for authentication, allowing you to grant access to specific users and groups within your organization, and you can also provide secure access to external users. Now, if you're familiar with role-based access controls, or RBAC, to assign specific access privileges, in DevTest Labs, we simplify this even further with predefined roles that enable access only to DevTest resources. These safeguards not only provide an additional layer of security, but help you to manage costs, ensuring Azure usage from only approved developers. You can then monitor usage and overall spend in the lab and get real-time cost projections to see how well you're tracking against budget. Now, once you've helped define the operational requirements of the application and development and test environments, responsibility for coding and building the application moves primarily to your developer counterparts. In DevOps, two terms that you'll hear about are continuous integration and continuous delivery. The idea here is that you build and test smaller code batches, deploying more frequently. The more frequently you deploy, the more you can experiment, and the more opportunity you have to change what you're doing if it's not working, or continue to persevere. As you can see here in Visual Studio Team Services, during continuous integration, the build and testing of code is automated every time a team member commits a change to version control. Now, this is important because developers often work on different parts of an app in isolation. Committing code triggers the automated build system to grab the latest code from the shared repository, and then testing and validations performed against the app as a whole to reduce merger conflicts. VSTS gives you complete traceability to see everything in the build, including changes to your code, reviews, and test results. Now, continuous integration as part of DevOps is a critical area for you to partner with your developer counterparts so that you can influence the right IT operations criteria to test against, such as making sure the app can scale or that you've accounted for load balancing, in order to catch issues early. From there, the build can be automatically picked up by your chosen continuous delivery tool. Here, for example, in Visual Studio Team Services Release Management, deployment of the app is automated, ensuring the right approvals at each stage. Of course, your developers can continue to use their preferred open source tools such as Jenkins, Travis CI, and Spinnaker at various stages of the CI/CD pipeline to achieve the same. Once the app's in production, this leads us on to the next sequence in the DevOps lifecycle, monitoring. Now, both developer and IT teams equally can detect and diagnose issues by using Azure Application Insights. You've got access to live performance telemetry that ties directly back to the code, making it easier to make fixes. And you can also track incident response and service health through Azure Monitor. Ultimately, you can get to a point where you can detect an issue before you get that help desk call. The overall advantage here is that because we have a standard process, you can keep production fresh with the shortest path from code check-in to deployment, and what's more, the resulting code now has operational awareness baked in. So as you saw, Azure provides a unified environment for the DevOps process, helping you to foster a mutually beneficial partnership with your developer stakeholders as you develop and ship new apps and services. You can learn more with virtual demo experiences and additional training with the link shown, and keep checking back on Azure Essentials for more topics. Thanks for watching.